run something off for you so you don't have to remember these kind of things. But the biggest thing when you're talking about conversions, you're going to take and you're going to either switch it from something big to something small or vice versa, right? And when you do this, obviously, the United States is kind of the black sheep of the whole world because we're still in standard metrics and everybody else uses the metric system. The metric system is actually a lot simpler because it's all based off of 100. So basically, you're just moving your decimal place back and forth. When you're talking about the standard, which we use a lot for everything, you have to actually remember all of these things that are in this back cover. And even myself, I really don't like the cups and the fluid ounces and that kind of stuff. So make sure that you use this back of your book to figure this out. So what are we looking to do here? Well, again, you're going to make some kind of fraction. So converting units. We are going to basically make fractions and your fractions are going to show specific conversions. So for instance, if you had, and I'm going to use something really simple, if you had inches and you wanted to change it to feet, one of your fractions would show how many inches are in a foot. And it doesn't matter where you put the inches and where you put the feet. You can put the feet on the top or you can put the inches on the top. That doesn't matter. All right? But you're always going to make a fraction, and each fraction will be that specific conversion. Or your fraction will be over 1. So when you start out, your very first one will be whatever they give you in the problem. So again, if we go back to our inches to feet problem, we would say that we have 42 inches. How many feet is that, right? So my first one would be 42 over 1. Right? Now when we do this, we always want the same measure. So whatever we're talking about, one of the conversions will always have to have one of the same measures diagonal to each other. Why we want this is because if we can get it diagonal, then our units will cancel each other out. And whatever's left over then should be what we were going to do or what we wanted in the first place. So basically what we're going to do is make a giant multiplication problem, right? We're going to have something here and something here and whatever it happens to be. But you might have to do this more than once. Have you taken chemistry yet? Anybody? So chemistry would do this a lot. You're going to change things from one, but you probably have to do it in chemistry 3 or 4 times. And that's why the basis of this is kind of really important when you get into chemistry and physics and that kind of stuff. So, again though, if I had inches up here over 1, then I know that my inches have to be down here. And so on and so forth. So it doesn't matter what we're talking about, they just have to be there. So if this was feet, and that's my inches would cancel out and I'm left with feet at the end. But maybe I'm going to yards, so then I'd have feet down here, and I'd have yards up here. Now some of you might know the direct correlation or conversion from inches to yards, and you don't have to do that middle step. And that's totally fine too. But if our same unit is diagonal from each other, they'll continue to cancel each other out, and what's ever left over should be what the problem asks us to find. And then at the very end, we're still going to multiply straight across. Now, when you do this straight across, you got to make sure that you do the top and the bottom. You got to make sure that you do this for your numerators and your denominators. Now, the majority, I think, today are just one-step ones. So you take it and you do whatever they happen to tell you, but it's just one time. The last thing that you should honestly do, though, is just stop for a second and ask yourself, does this make sense? So if I have feet and I'm turning it into inches, should my answer be bigger or smaller than what I started with? Right? Is there more inches in a foot, or are there more feet in an inch? There's more inches in a foot, right? So if they tell me I want inches, my answer should be way bigger than the original problem. That makes sense? And so just stop for 2 seconds and think, does it make sense? Did I do it right? All right? So here we go. I got 8.7 kilometers, and I want to turn it into how many meters? Now again, this is a metric one, right? You might be able to just do this one without setting up any fraction, because again, the metric system is a lot easier as long as you understand these prefixes, right? How many kilos are there in a regular meter? Or how many meters are there in a regular kilo? Right? That's what you'd have to know. Otherwise, if you don't know that, now we're going to make our little fraction here, and it'll be easy for us. So again, whatever they give me, that's going to be my first one, and I'm going to always put that over 1. My second fraction is always going to be the specific conversion. So, how many meters are in a kilometer? 1,000. So, where does my kilometers have to go, though, in my second fraction? On the bottom. Because my km's have to cancel each other out, so I'm going to have my meters on the top. And you said there is 1,000 meters in 1 kilometer, right? So the second fraction that I have is going to be exactly what that book says. And you're just going to make it into a fraction. Now, I already got my meters, and that's what I'm looking for, so I only have to do it 1 time. And now I'm ready to come back and cross out my kilometers, and then I'm just going to multiply straight across the top and straight across the bottom. So again, if you knew that there was 1,000 meters in a kilometer, you could have taken the original problem and just moved your decimal where? 3 places to the right. Right? And again, why is it 3 places? Because there's 3 zeros, right? So I could have just went 1, 2, 3. And that's why the metric system is way easier than the standard units that we use. Because all you have to do is move your decimal. But again, if you don't know that, then you just set up this proportion in a sense, and you multiply straight across, and we still get the same answer, right? So it's what? 8,700? And 8,700 what? Meters. Don't forget your label. And then last but not least, does it make sense? Should, right? We should have way more meters than we should kilometers. Exactly. Kilometers, kilometers, same thing. All right? Questions with that one? So, 9,680 yards. And we want to convert that to miles. So, anybody know how many yards there are in a mile? Is there a direct one in the back?
1,760.
Okay. So, let's just say that you don't have this. Does anybody know a direct relationship between anything and miles? How many feet are in a mile? Not looking at the book.
1,180.
Okay. So, if you didn't know the yards, let's just say that we didn't have the book, and you had no idea what the yards thing was. But a lot of people probably know that there are 5,260 feet in a mile. Right? 280, sorry. So let's just do this with feet so we show you how to do the multiple one. So again, I'm going to start out. Whatever the book gives me as the problem is going to be my first. And then I don't know how many yards there are, but I do know how many feet there are. So I'm going to take and do my yards to feet as my second fraction. So how many feet are in a yard, or how many yards are in a feet? 3 what? 3 feet are in 1 yard, right? So again, I'm just filling in what I know. Now I come back and I say, well, now I know that there's 5,280 feet in 1 mile. Now again, if you had the book or you had the table, you would have just done this in 1 step, which is fine. But then, so I got my miles up here, and if I come back, my feet should cancel out, my yards cancel out. So now I'm ready to do what? Multiply straight across the top, multiply straight across the bottom. And so we get what? 0.4202, 29 over 5,280. And this would be miles, right? All I did was multiply straight across. The last thing I should do is see is, does 5,280 go into 29,040? Now either way, even if it's a decimal, I know we've said we don't really want decimal numbers at the end, but in this case it makes a little bit more sense. If somebody was asking you how many miles that is, and you said, well, it's this fraction, would that really make a whole lot of sense? Probably not. So in this case right here, I punch this into my calculator and get a decimal. Well, did you get it? So this is 5.5 miles. And that makes a lot more sense than that fraction, right? Okay? So again, if I'm going to use the book, I would have done this in 1 step and we would have got the same answer. It just would have been a little quicker. Let's try another. 24.8 quarts equals how many gallons? Try this on your own. So we start out with quarts and then we go to gallons. Is there a direct relationship? That's what you're seeing. Know what you got?
What I got?
Miss. I'm gonna call you Miss Paul from now on. You're obnoxious.
I didn't notice the time was this.
Obnoxious. Look at him. OB. How do we do? 6.2 gallons. Okay, let's try one more at least. 7 gallons, and I'm going to convert it to pints. This one doesn't have a direct relationship. So you got to do it 2 times.
And the definition.
Yeah.
Extremely unpleasant.
There you go.
I got homework.
What's that?
Can we just like use the book on homework, or do we have to?
Yeah.
Okay.
But you just gotta show me how you're gonna set it up, either way. And I think I gave you a little thing for the test too. I gave you this back here. Alright. Alright. Everybody good with 56?
I want that, it doesn't make sense.
It doesn't make sense?
No, I get it. I'm just thinking about something else, I guess.
Like what?
Because I'm trying to think, so I work at the parlor,
Okay.
and we would not be able to get 56 pints out of seven, I thought it was 1 gallon of ice cream.
70.
That makes sense then. I guess.
Okay, see? Makes sense though.
Well, if I read it right, then maybe that would help me.
Probably would, you're right. Okay. Any questions there?